Hey everybody, we are back in business here in lesson 4B doing some trig antiderivatives or trig integrals requiring two different types of u substitution. And I just discussed in part 1 video that the integral of cosine squared x dx is actually equal to x divided by 2 plus the sine of 2x all over 4 plus c. And this is something that you should commit to memory here, so I'm going to put down memorize this. And because it's useful, and you don't have to keep on deriving that with these facts from pre-calculus right here. Stuff that we already know. Okay, so just memorize this result and be able to apply it like in the next one here. So let me scroll down here, number 10, and let's continue here. I know that this is not cosine squared of x, it's cosine squared of x divided by 4. So I'm going to let u equal to the angle here. Remember, this is the angle. That's the first type of u substitution here. And u is going to be equal to x divided by 4. That means the u dx is just 1/4 dx. Okay, and since there's no 1/4 here in the lead coefficient, looking right there, I'm going to multiply both sides by 4 and write 4 du is equal to dx. So I can take this portion right here and substitute in 4 du. So I can rewrite the integral in terms of u. So now, here we go. Instead of cosine squared of x divided by 4, I have cosine squared x, cosine squared u, because u is x over 4. And dx is the same thing as 4 du, so times 4 du here. I'm going to distribute that 4 out. I'm going to rewrite it as 1/4 times the integral. Not 1/4, but 4. It's a mistake. Let me fix that. 4 times the cosine squared of u du. Okay. Now, I already know from my previous example that that's equal to x over 4, but our variable is not x, it's u. So I have u divided by 2 plus sine of 2u divided by 4 plus c. All that's being multiplied by 4. So using the prior result, okay, I know this is true. I don't want to do that again. It's not necessary. I already know what it is. Okay, so I'm going to, let's see, I can distribute through the 4 first and write it as 4 times u over 2, which is just 2u, plus sine of 2u. 4 divided by 4 is 1. Let me see. Plus 4 times c is just c. Okay. And then, what do I have? Well, let's see. I have to substitute in x divided by 4 right in here. So I have 2 times x divided by 4 plus sine of 2 times x divided by 4 plus c. So that becomes x divided by 2 plus sine of x halves plus c is my final result. Okay? And you're happy at that point, and there you go. That's using the prior results. Much, much easier. All right. So let's see here. Let's see. Let me pause here for a second. Okay, let's try these last few integrals here. I'm going to let u equal to the inside function here, the one that's being squared. So this is an example where you let u equal to the entire function here. And I let u equal cosine x here because I know that the derivative is sitting right next to it. It's going to be negative sine. Don't worry about the negative or positives. They can always be distributed out of the integral. But I know that the integral of cosine is negative sine, and sine sitting right next to it. So this is a good choice. See, du is equal to negative sine x dx. I can rewrite that as negative du equals sine x dx here. And so let me just rewrite the integral over here so I can see it a little bit better. So I know this portion right here is just a negative du, and this is my u. So when I rewrite this, I can distribute out the negative and write it as u squared, all right, du. All right, it's that simple, believe it or not. And that's equal to negative u cubed divided by 3 plus c. All right, and u is cosine x, so I get negative of cosine cubed x, all right, divided by 3 plus c. You can write it as a negative 1/3 if you want to bring that in front. Okay, on this next one here, I want to, let's see, do you let u equal to 2x or the entire function? So in this case, sine is being cubed, so I'm going to use the inside function here. I'm going to let that be my u. So u is going to be equal to the sine of 2x. Okay? So I'm going to let it equal to the entire trig function. When I take the derivative here, du, I have to use the chain rule. So I get derivative of sine is cosine, so I get cosine of 2x times the derivative of the inside function 2 dx. And so I have, I'm going to divide by 2, so I get 1/2 du is equal to cosine of 2x dx. Now, why is that important? Well, this is sitting right up here in the numerator right here, and that's 1/2 du. So when I rewrite the integral, I get the integral of 1/2 du, just straight substitution, all divided by u cubed. Okay, sine's being cubed right there, so when I let u equal sine of 2x, I'm going to have to cube that. That's why I have a u cubed there. And then bring out the 1/2, so I get 1/2 times the integral of u to the negative 3 by bringing that upstairs. I rewrite it in exponential form. That's equal to 1/2 u to the negative 2 divided by negative 2 plus c. So that's going to be equal to a negative 1/4. U to the negative 2 is going to be bring downstairs. So 1 over u squared plus c. Okay, so let's just finish up and clean that up. We're going to have a negative 1 divided by 4. Negative 1 over 4 times u to the squared, so sine squared of 2x. Alright, all that's in the denominator. 1's in the numerator. Plus some constant c. There you go. Alright, the next one here, you want to pick a function whose derivative is somewhere else in the integral. And the derivative of secant is secant tangent, which is not in the denominator, so that would be a bad choice. Derivative tangent is secant squared. That would be a good choice. So your choice of u really matters here. Pick the one. Pick the function whose derivative is somewhere else in the integral. So when you differentiate, I'll tell you guys, those people watching the video here at our school, or watching the video at my school, we have so many crazy interruptions, not even funny, and I can't stand them. All right, you ought to know that. So anyways, bear with me here. Du is equal to secant squared x dx. Right here, notice it's in the numerator. So that whole thing is du here. So that is du, and this is going to be u squared. So when I rewrite the integral, I get 1 over u squared du. It's real simple. And that's going to be equal to the integral of u to the negative 2 du, and that's going to be equal to, let me see, u to the negative 1 divided by negative 1 plus c. And that's going to be equal to negative 1 over u plus c. Right here, and when you substitute back in tangent, you get negative 1 over tangent x. Alright, plus some kind of constant. Okay, and the last one. Okay, and then last one here, what I'm going to do is I'm going to rewrite this right here as cosecant squared x times cosecant x cotangent x. And the reason why I want to do that is because I know that the derivative of cosecant is cosecant cotangent. So I'm going to let u equal cosecant x, so that when I take a derivative, I get cosecant x cotangent x dx. So notice this whole thing here is du. Okay, so when you integrate, you're going to, or rewrite this, you get u squared du. Actually, I forgot the negative sign there because I'm being interrupted. So you're going to have negative just read out the negative, I get negative integral of u squared du. So I get negative u cubed divided by 3 plus c. Bring it in, so you get, bring the x in, you get negative negative cosecant cubed x here plus c. I forgot about the 1/3. Okay, sorry about all the interruptions, but there are the last few examples. See you guys tomorrow.